Hello everyone. Today I'm happy to present PropMask, a mobile mask detection system for health situation awareness developed by Cemil and me under the direction of Professor Lynne Grewe at iLabs CSU East Bay. The PropMask system has two subsystems, Mask Detect and Mouth Nose Detect, and is developed as an Android application along with other systems in the larger project COVID ID. To give an overview, the image in the right-hand corner here shows the Android interface for our system. The first subsystem, Mask Detect, directly detects people wearing masks correctly, incorrectly, or not wearing any, whereas the second subsystem, Mouth Nose Detect, is inverted problem implementation. It solves the mask detection problem by examining the opposite evidence, that is, it detects mouths and noses confirming incorrect mask, no mask situation. In addition to the detection of properly wearing masks, PropMask also provides visualization of risk calculated by crowdsourced report in a map interface. Here is a screen recording of our system in action. Selecting the mask option in the COVID ID app gives the user options to launch mask detect and mouth nose detect. We'll see the mask detect system in this video. Mask Detect subsystem detects three classes. When the nose and mouth region is completely covered, the system identifies as face with mask. And when there is a mask, but the mask doesn't cover mouth or nose, or both, it is identified as face with mask incorrect. And when there is no mask on the face, the system detects face no mask. In this frame, we can see people inside a retail store wearing masks, and our system is identifying them correctly. We can see the instances of face no mask and face with mask. This is the screen recording of mouth nose detect subsystem. Some parts of nose may be visible when properly wearing a mask. So the mouth nose detect is trained to detect the nostril area, that's the lower part of the nose. In this subsystem, we have two classes, nose and mouth. The presence of either matches with face no mask or face with mask incorrect classes of the mask detect subsystem. Wearing masks is now mandatory in many places, and it is hard to monitor large groups of people manually. One of the possible use cases for our system is supermarkets. Our system can be used by supermarket staff for monitoring if people are wearing masks correctly. The real-time visualization interface can be displayed on digital screens. Once the user logs in and the system makes any detection that passes the confidence threshold, then the detection data is stored in our cloud data storage as COVID records. Here is a face with incorrect mask detection and the corresponding COVID record created. Each COVID record represents a single detection and includes bounding box, confidence score, image URL, detection class label. In this case, it is incorrect mask, face with mask incorrect. User's current location, record type, risk, and timestamp. The record type mask indicates that this COVID record was created by the PropMask system. The image URL points to a diagnostic image created of the scene that is stored in the file store. The risk associated with location is calculated and is displayed on the map as red, yellow, green mask icons representing high, caution, low risks, respectively. As you can see in this video, clicking on the mask icon shows the risk, certainty, and the type. For face with mask, incorrect mask, and no mask, the associated risk will be in the low, cautionary, and a high risk ranges, respectively. And the actual value is related to the confidence score. Also, for the detection type, mouth and nose, the risk will be high risk range and the actual value proportional to the confidence score. Motivation behind the development of this system is given the rapidly spreading of COVID cases, Public health officials believe that face coverings can substantially slow its transmission, but the face coverings work the best if they're adopted widely. PropMask provides real-time visualization for risk related to improper mask wearing, thereby providing better health situation awareness to the general public. It also assists in better personal safety by allowing users the choice of knowing and avoiding places where there is a potentially high risk due to the improper mask wearing. Training system for our machine learning model is developed using Python, TensorFlow framework, and object detection API. Training system is broken into 3 stages. The first stage involves labeling the images and mounting the images and annotations on Google Drive to the collab. The images scraped from the web were labeled using Label IMG tool, which saves the annotation in Pascal VOC XML format. In the second stage, we pre-processed the image, generated label maps, TF records, and retrained with a trained generic object detection model. We considered retraining with the selected models of SST MobileNet, efficient at D0, and efficient at D4. In the third stage, we analyzed the TensorBoard graphs, the COCO evaluation metrics, and inference on the test images. Here is the system diagram of PropMask. At first, images are collected and annotated with label IMG and retrained with efficient at D0 model for both the subsystems. The output of mask detect and mouth nose detect training subsystems are saved model, which stores both the weight and architecture of the model. We convert this saved model to TF-Lite format, and this format is deployed in the Android application. The Android device camera is then used for capturing live frames for running inference. The Android inference portion of TF-Lite makes calls to the Android Neural Network API to help improve performance. TF-Lite on Android is currently supported by C++ API, on top of which there exists a Java wrapper for Android developers. GPS and Google Maps API is used for tracking location and displaying risk visualization. The user authentication is done with Firebase authentication and Google as identity provider. Code records and frames are stored in the cloud Firestore, and the whole application sits on the top of Firebase Cloud. Our mask detection system is robust with 2 different approaches in evaluating the proper wearing of masks. Mask Detect subsystem, which performs well at an average precision of 83.2%, and the Mouth Nose Detect subsystem has achieved an average precision of 69.5%. This work is a proof of concept application of how computer vision and machine learning for the purpose of detecting the proper wearing of masks to provide health situation awareness. Major area of future work is around increased accuracy and speed of our models. Fine-tuning of parameters like learning rate and possibly increasing the amount of data in our dataset could yield somewhat higher accuracies. With regards to the speed, the major issue is related to TensorFlow Lite's lack of full native support of efficient at D0. While SST MobileNet has lower accuracy than EfficientNet, it offers improved speed. Another interesting avenue would be having a third subsystem specifically to detect outlier masks, such as photorealistic or any unusual ones, as shown in these images. For COVID ID resources, feel free to visit our GitHub repository or watch our YouTube video or visit the iLab webpage. Thank you.